So how do I enable NBAR feature? Do you see? Do you see?
It's not connected. It's simply loading.
Connected? Not yet. Connect. Let's take a look at how to configure NBAR. Okay, in your router, I'll be taking a look at just in this router one. So class map, okay, match any according to the question we blocking Twitter and Facebook. Let's give it a name, NBAR. How do you enable NBAR? To enable NBAR, the first thing you need to do is match protocol HTTP. NBAR is for HTTP, and what you're doing is URL. Okay, I want to block twitter.com. I can use my regex regular expression where I'm specifying in the field in the URL the specific information in the URL. For now is, let's say, Facebook. I'm gonna block every packet having this content. When I hit enter, see the time it takes for enabling it. Actually, this feature is getting enabled. It takes a bit of time. It comes back. Okay, so now you'll see the next time is not gonna take so long. For what again? Twitter.com. Didn't take so much. The only first time is for initialization, where initialize this feature. It takes some time. So you enable your NBAR. The second thing is this is classifying your traffic. I'm classifying everything coming in the HTTP URL having content what? Facebook.com or Twitter.com. What do I want to do with them? Let me specify my action. Policy map, I'm gonna call it PM. Let's call it PM NBAR. Okay, in my policy map, call the class. What is my class? NBAR. And here, what? Drop. This is what the question says. If everybody is going for Facebook or Twitter, drop them. Okay, and how do we apply them? In the interface. Which interface? F0/0, the incoming interface where your user are connected. So over there, service policy, input what? PM NBAR. This is how we do it for NBAR. If we just can recap what we've done for NBAR, you can even block, let's say we want to block again another thing. Let's say we want to block what? YouTube. How do we do that? Class map, okay, match any, we calling the same class map, okay, NBAR, and then what? Match what?
HTTP
protocol HTTP. Okay, and then what? URL. In the URL you specify, let's say, YouTube. Anything having the content youtube.com in the URL selected. Classify your traffic, then specify the action in your policy map. My policy, how did I call it? PM NBAR. Okay, call your class. My class is NBAR. And then what? Oh, no even need to do it because in this policy my action is drop. I can also do something. I can police it. I can set something. Let's say I want to set, you can even set what? I can set the QS. This is for layer 2 information. You can set the course, you can set the precedence, some IP value. If you want to do quality of service, I want to give it some information that I will use later. to give it maybe extra bandwidth. You can do lots of things with it. But what is important for us is the action should be dropped. So this is how you do it. If you just see show run section plus, the first thing we've done is class map match any. Match any is not the default. The default is match all. Okay? But actually we're using match any because if either is using one of them, block. Okay? You might not use YouTube, but he's using Facebook, block him. You might not use Facebook and Twitter, using YouTube. If you use any traffic going to YouTube selected, then later do what? Block. So if you see, let me also show one. Select policy map. You see that over here I'm calling my class and my action is what? Block. And then in my interface, which interface? F0/0. Over here my service policy is calling my policy map. So how did we do it? If we can recap for NBAR. Step 3, NBAR initialization. Okay, first thing we've done is, this is for lab 2, I think. Yeah, lab 2. Step 1, NBAR initialization. We call the class map match what?
Match
any.
Yeah.
Okay, how did we call it? NBAR, and then what? Call it here. Match what?
Protocol.
Match protocol. Okay, HTTP URL. Then here specify whatever you matching with Facebook. You can even try it with the lab we just gave. Okay, Facebook and what? Match. Also match protocol, HTTP URL. Now twitter.com. Okay, then another one we just add is match protocol, HTTP URL, YouTube. Okay, then the next thing is, that was classifying your traffic. Now specify the action, policy map. We call it PM NBAR. Here, call your class. My class is NBAR. Okay, and then specify your action is what? Drop. Then apply it. Step 3. Apply it in the interface. Okay, service policy input what? PM NBAR. Call your. So this is step 1. NBAR initialization. Classify the traffic. This is how you also do your QoS. Then step 2, specify the action. Then step 3, apply it. That's how you do it. If you see, even for our ACL anti-spoofing, which things did we do for lab 1? If you take a look at for lab 1, what did we do? Let's just see the question again.
We created an ACL, we blocked the private IP addresses. Then we created an SCM which helps us to block
all those private IP addresses. Okay, how did we do it?
series list.
If you see for lab 1, how did we do it? Access list. Okay, access list, yeah.
1 I think we used 1
Yeah, 111. Okay, then
we use
deny IP. Okay,
yeah, any.
first thing is
Okay, yeah.
then network. Okay, which our wildcard mask is what?
0.255.255.255.
Exactly, yeah. 0.255.255.255 to which? To any.
Yeah.
Okay, then the next thing is access list. Okay, 1 deny. This time around is for what? 172.16.0.0 through 0.15.255.255 to what? Any. Okay, then the next thing is access list. 111 deny 192.16.0.0 match it, then don't match. Okay, to any. This is how we have done it. And for RPF, this is for RFC 1918 addresses, which is bad.
Then this, I think we
apply it.
Yeah.
Yeah, okay. We have to apply it. How did we apply it? Interface outside, right? We apply it in the outside interface.
Yes.
S0/1 IP access group. What?
In.
111 in. Okay. This is for task 1. For task 2, it was our RPF.
Yeah, then we have to block.
Yeah.
Yeah, I think before this we did one practical where we ping, we try to send a reply message.
Yeah. So
to the inside network.
That RPF reverse path forwarding, where actually we are allowing only the reply packet.
Yeah.
And actually the attacker will use the reply packet to send bad packet to our network. So how did we actually implement this? First thing is, if you take a look at it, just wanna take some water. The first thing we did here is this command for RPF. Okay, IP verify unicast, source reachable via RS, allow default. You see that look at to the routing table to reach only what? The default gateway. Okay, don't look for the routing table for this network. Everything that you're seeing has got another destination, or can be sent as a packet, can be that you send the packet back to another interface. Use only the default gateway to send it back. Okay, but we have seen that there's sometimes exception. We can also apply exception that yes, I want to drop every packet coming from this interface and going back to another interface, but also I would like to allow a specific packet. So how do you put your exception? Actually, if there's exception for a 20, you see that we have something. Let me just delete this thing. Yeah, let me just delete. So the exception to it is something. Let's say the exception is done in a way where we use actually an access list, okay, to permit whatever traffic you would like to permit with this this command. If there's any traffic you'd like to permit, actually, that you don't want this command to be applied to, you can use any access list. Access list, let's say standard, call it 20, and over here I'm saying permit. Let's say I'm permitting host 20.1.1.1. Okay, and how do I apply it? I'm applying it in my interface facing the internet. I'm just gonna copy this command. Yeah, and then call your access list 20. So actually what happen is, if this network comes from another interface, and even though it's reachable from another interface as well, I'm doing what? I'm permitting it. I'm allowing it. Says, yeah.
No, that is really not.
Yeah. So it says yes. Oh. Okay. So it says yes. If it comes from another interface, check what does the access list says. The access list says what? Permitted. And then another thing we've seen is sometimes, because this command does what you call a silent drop, he's gonna drop it, but he's not gonna tell you that he's dropping packets. What if you'd like him to log it? Whatever I'm dropping, I want to know. Okay, how do you do that? Same thing, access list. This time around is for logging.
Yeah.
Okay, access list what? Access list, let's say standard. You can also put a extended. If by example you know the source and the destination.
Yes.
Okay, let's say this 10 is going to this 100 and I'm dropping only this this thing there.
Yeah.
You can also put an extended. So standard, let's say this time is also 20, but over here I'm denying any, and at the same time log. Whatever I'm denying, I also want to log it. Then call it inside your interface. Just copy this.
I think we should change that access list.
Which one?
Maybe give some 21 or 22.
Okay, yeah, sure. So we give it 30 and yeah, apply 30. So everything is here, is already denied. Check what the access list say. The access list says what? Yes, if anybody is using this, is changing his reachable interface, drop it. Yeah, deny it, but also log it. Okay, so this is how we can actually use RPF. And then we've seen NBAR. Everything is there actually. So I guess lab 1 and lab 2 is done. We might go to lab 3 maybe later. I don't know if you have any question.